the rules governing them, and demonstrate that. So, like I said, like in the phone book, why is it the house number, the street address, the direction, the city, the zip? Why is it in that order? We don't necessarily know that. That's just how it is for us, and we're going to learn for electrons why is it in a certain order. All right. So to start with, we want to just get the rules out. So if you have these rules already, this is video 4.3, or you can get them now. But just get them down. We're going to apply them next. But right now, the Aufbau principle: the lowest energy level receives the electrons first. That's it. All right. You build from the bottom up. So again, how do I know what order to put your house address in? Well, this diagram kind of shows you that, all right? And does this look familiar to some people? You've seen this? I'm going to show you how to make it, and then how it tells you what order to put the electron's street address or electron configuration in, okay? So let's go ahead and look at our first diagram of it. The first row, so the first energy level has one thing in it, right? It's the first one. It has one thing, 1s. That's like your street number, energy level 1. What row do you live on? A sphere, right? That's its shape. Second row gets two things, 2s, 2p. Second energy level, row 2. I live on a sphere, or I could be on a dumbbell. My electron could be on dumbbell road, right? Either a sphere road or a dumbbell road. Third one, how many is it going to have? 3. 3s, 3p. What comes after p? D. 3d. Again, sphere, dumbbell, kind of like a clover. Fourth one, 4s, 4p, 4d, and 4f. Right? But do we need to know f for our class? No. So I kind of ignore the fact that it's there. Simplify things. We don't need to know what's there. Don't put it there. Then we have 5. And then 6. Alright, and you can do, right? You could keep going, but we're going to stop there. That's as high as we go. We actually go to 6s is the highest that we go. Alright? So, again, how do I use this, though, to know what order to put it in? Well, Aufbau says build from the bottom up. So I'm going to start at the lowest energy level, my first road, and I'm going to build from the bottom up. So the first energy level I would drive through, right, would be 1s. And then I'm going to continue my path. I just kind of loop back around and I go diagonally down every time, right? So the next is 2s, right? What comes after 2s then? 2p, 3s. Then what? 3p, 4s. Then 3d, 4p, 5s. Then 4d, 5p, 6s. And for us, that's as high as we will go, ever, for any of the electrons' street addresses or electron configurations, in that order, all right? So we can use that diagram to help us get there. Two of the other rules that we're going to apply next, Hund's and the Pauli exclusion principle. And again, just get them down now, and we're going to apply them next. One electron in each orbital. Everyone gets one, all right? Just know that. Everyone gets an electron. The exclusion principle, at max, I can have 2 electrons with different spins, okay? At max. 2 electrons with different spins. So basically, no 2 electrons, just like Brennan, your house address is very different than anybody else's. You can't have the same street address. 2 electrons can't have the same 4 quantum numbers. All right? So those are just rules to have down, and we're going to apply them. I'm not going to ask you on a test, like, what is this definition? I won't ask you that. In the practice quiz I will, but use your notes. Right? On the test, I'm just going to ask you to apply them, and that's what we're going to do next. How do we actually write these notations? So the steps here, to actually write an orbital diagram notation, if you like stepwise, here it is. Electrons, we represent them as an up or down arrow. It's either spin right, which is positive, or spin left, which is negative. Energy and the sublevel is written below the box or line. So again, an S, it only has one line because it's a sphere, right? No matter which way I turn it in space, it's not facing a different way, right? Whereas my P, what is P? Dumbbell, right? I can turn it side to side, up and down, in and out, and get it to face different ways, right? Energy increases as I go up because I kind of put them as staircases, so they're like stair steps. And you can also know each one of those is a different orbital, right? And they kind of build on top of each other. They build on top of each other. And then you basically apply the 3 rules that govern electron configurations. Alright? So the best way to do it is to just look at an example. Alright? And just dive in with an example. So, let's go ahead and do 14(7) nitrogen. We'll do nitrogen first, okay? Best way is to dive in and just to write it. We're going to write the electron configuration for nitrogen, okay? So again, let's look at our example here. For nitrogen, how do I know what order to go in, right, for nitrogen? How do I know what correct order to put the electrons in? First and foremost, how many electrons are in nitrogen? 7, right? I have 7 electrons in nitrogen. So, my diagram, if I go back to it, one S, 2S, right? So I'm going to go 1S, 2S, then 2P, 3S. Right? Electrons, how do I represent electrons, Alex? Up and down arrows is an electron, alright? How many electrons can I put per line? 2. So 1, 2, 3, 4. Everyone gets one on my way up. So I'm at 4, 5, 6, 7. That's my electron configuration for nitrogen. Alright? Check your work. There's the correct answer. Alright? I end up not needing the 3S. I don't need it. Okay? Mike.
Why do the 1S and the 2S have 2, but only the...
Well, if I had more, so for example, right here, for boron maybe isn't a good example. There you go. I don't have enough electrons to fill them up. I don't have enough electrons to double them up. So what I do for other ones, if you do one like neon that has 10 electrons, then I'm at the 2p, I start doubling them up because I need 10. I'm at, here is 1, 2, 3, 4, 5, 6, 7. Everyone gets one first before I start doubling them up with different spins. So then I'm at 7, 8, 9, 10.
Alright, what?
Okay?
That makes sense.